My dear students, I am Dhananjay Gadre and I teach at the Electronics and Communication Engineering Department of NSUT. If you are here because you have always wondered about this course called Electronic Design Workshop, then you are at the right place, because in this video I am going to talk about issues related to this course. I am going to address all your concerns, real or imaginary, about this course. We are going to cover that when you complete this course, what learning you will achieve, what skills you will acquire, what experiments you will perform, what syllabus you are going to cover, and very importantly, since this is a very unique and extraordinary course, very different from all the other courses that you have undergone till now, what project you are going to build during this course. So let's go. Electronic gadgets, they are everywhere and we are surrounded by them. In fact, as I record this video, I am using a video camera for recording this video. Behind me is a smart board. I am using so many gadgets at home, at office. For example, I am using this remote control to control the temperature of this room. I am using this light meter to know what is the intensity of light in this room as I record this video. I am using a laser pointer. It is not a laser pointer, it is a laser distance meter which allows me to measure distances. I am using a vernier caliper, a digital vernier caliper in my lab. I am using a mini weather station that tells me the temperature and humidity in my office. I am using a data logging temperature sensor. I am helping a startup and they want to monitor the temperature in their greenhouse over a length of time. So, they put this device in their greenhouse and record the temperature and store it in this device, and then maybe after 2 months or a month they can download all that data into their computer. I am using at home, I am using this blood glucose meter to measure my blood glucose levels, alright. So, the point is there are so many electronic devices that benefit our life from the time we wake up in the morning to the time that we go to sleep. Now, the question is what kind of skills are required to be able to build and produce these gadgets, and increasingly such gadgets could be standalone, but as we know a new crop of devices is coming up called Internet of Things devices. These devices connect these gadgets to the internet, and a very common and famous example of such devices is this phone pay or Paytm soundbox. Now, if you had skills for designing such instruments and gadgets and systems, you would be eminently employable. And this course, Electronic Design Workshop, actually gives you the skills so that you can design such instruments, you can design such gadgets, and you will be eminently employable in the startup ecosystem or the traditional core industries. So, let us see what this course offers, what this course covers, what skills this course gives. Now, since you want to design electronic systems, obviously you need to understand what sort of electronic components exist, which component to use for a given application. So, in this course we are going to cover basic electronic components, much more than what you have covered till now. Then using these components, how to build useful circuits. After that, most of these, I would say all of these electronic gadgets use an embedded computer, and so we must learn about microcontrollers and microprocessors and how to use them in such systems. We are going to learn about microcontrollers and microcontroller platforms. Then we will learn about microcontroller programming and also IoT programming. We need to learn about sensors and actuators. Sensors will sense the physical environment, actuators will help us control the environment in some way. For example, you may have motors, you may have relays, you may have servo motors and things like that. Then no electronic system works without a suitable power supply. So, in this course you will be taught about various power supply topologies and energy storage systems, because many of these gadgets are battery driven. And once you know all these basic elements, for any given project you will need to learn how to capture the user requirements for any given project. Once you have all these elements under your belt, the next thing to do is to translate the requirements into something tangible. So, here you are going to learn how to draw schematic diagrams using a suitable CAD software. From the schematic diagram, how do you make a PCB layout? Once you have made the PCB layout, how to create a PCB, how to fabricate a PCB. There are PCBs of various types, single layer, double layered, multi layers. And once you fabricate the PCB, you get all the components together and you solder these components on that printed circuit board. So, you need to learn how to solder printed circuit boards. Once you have soldered it, you would like to test the PCB, and for testing you would need to learn how to use various test and measurement instruments. You have used such instruments already in the lab, for example, a oscilloscope or a power supply or a multimeter, but we will go in the details of the operation of these devices. Once you have tested the circuit, you will need to learn how to build an enclosure, because you are not just selling a circuit, you are selling a system. So, you need to learn how to build suitable enclosures, and what are the tools for building these enclosures. We are going to learn about CNC machine, laser cutter and 3D printers, the software for creating the enclosures and then translating the software files to these devices so that you get a suitable enclosure. Then you need to learn how to integrate the circuit that you have built into the enclosure and test it, and at the end how to document the system. So, let us go into the details of this. As you know, this course is titled Electronic Design Workshop. The course codes are ECE ECC 402 and EI ECC 402. This is a 4th semester course for ECE and ECE IoT students. So, in this rest of the lecture, I am going to cover a little bit of background, the details of the syllabus, the books that we are going to cover, the list of practicals, a project that you would have to do and how to document it all. Now, most of the courses that you have covered till now follow a certain protocol that is explained or mentioned as LTP, that is how many lectures per week, how many tutorials per week and how many practical hours per week. Most of the courses that you have covered till now are either 302 or 310. As I mentioned, this is a very unique course because this does not follow these numbers, it has 204. That means we are only going to have 2 hours of theory lectures per week, but we are going to spend 4 hours in the laboratory. Obviously, the objective of this course is a lot of activity, lot of work in the laboratory. Also, let me give you a little bit of background of how the courses have evolved from first year, first semester till the end. You would have courses which would cover basic sciences such as physics, chemistry, mathematics. Then building upon the expertise and skills that you have learned through these courses, you would have courses which talk about semiconductors and semiconductor devices. From these devices you will learn about various circuits, they could be analog circuits or they could be digital circuits. Then you would go and graduate to building systems, and once you learn how to build a system, you would learn how to create a prototype, and from the prototype will become a product. So, this entire journey will once you learn about this journey, you will become a true engineer. Now this course tries to give you a flavor of creating product prototypes, and that is why this is a very unique course. So let us see the syllabus. The course outcomes as listed in the syllabus, I have already gone in detail, but basically you should be able to identify and understand the operation of basic electronic components, ICs, microcontrollers and sensors. You should be able to use various sorts of laboratory test and measurement instruments, and you should be able to, using these instruments, you should be able to debug and make your circuit working. Then you should be able to learn about mechanical processes for creating printed circuit boards, for creating enclosures, and at the end of it you should be able to integrate all this knowledge together to build a working electronic and or IoT project and system. So this is these are the course outcomes. As you know, our syllabus is split into 5 units. Unit 1 is Introduction to Electronic Components and Lab Instruments. These are the details, you can look up the details on the course web page. Components, you may have used some components till now, but during this course we will cover far more components than you have used till now. You see here are types of resistors, various types of resistors, surface mount resistors, leaded resistors, power resistors, potentiometers, resistor networks. Then we will be using capacitors of various types, not just the electrolytic capacitors, but ceramic capacitors, mica capacitors, and then we will be using inductors. Then we will be using a lot of connectors, because connectors allow us to connect integrated circuits and circuit boards. Then we have integrated circuits of the types such as a microcontroller or an op amp or a timer, and again these integrated circuits come in various shapes and sizes, from very small ones to large ones. And we also cover indicators such as LEDs and 7-segment displays and graphics displays. To give you an idea about the scale of components, things are shrinking so rapidly. For example, here you can see a integrated circuit, and it is no ordinary integrated circuit. This is actually a microcontroller which I have put on my thumb, and for size comparison I put a grain of rice, and there are 3 other components. There is a capacitor here, there is a LED here, and this is a resistor. So this is the type of components you are going to deal with in this course. Unit 2, we will have Introduction to System and Product Building Tools and Processes, which means creating schematic diagrams and making PCBs out of that. Then how to solder things, how to solder circuits, and how to use the CNC milling machine or 3D printer and build your enclosures. As an example, this is a schematic diagram that you see in this presentation here, and from this schematic diagram this is the board layout that is a result of it, which is of course does not happen automatically. You as a student will have to create it, and once you have this schematic, this board layout, you can fabricate a PCB out of it. Then in unit 3, we dedicate ourselves to learning about various power supply topologies and energy battery storage systems. In unit 4, we learn about Arduino microcontroller. Arduino is a very popular microcontroller platform. You can use other microcontroller platforms too, but Arduino is very common and popular and inexpensive. So we are going to teach you about Arduino architecture, how to write software for Arduino, how to write and connect sensors and actuators to Arduino, and so on. And in unit 5, we are going to deal with communication and networking, because as I mentioned, increasingly our electronic gadgets are connecting to the internet. So in unit 5, we are going to talk about various communication protocols. We will see how to connect to the web server, and at the end we will have some electronic and IoT project examples. So this is the coverage of the syllabus. The books that we are going to follow, there is a whole list of these books, but I will tell you there are 3 or 4 very important books that you must regularly consult even outside this course, and one of them is The Art of Electronics. This is into its 3rd edition. It is a 40-year book. It is a extremely well written book, and I urge you to refer to this book as and when you face a problem in electronics. Then you have a series of 3 books called Encyclopedia of Electronic Components volume 1, 2 and 3. These are very beginner kind of books, and I recommend you use them. And of course, there are books on IoTs and programming Arduinos and Git and creating schematic diagrams and creating board layouts. List of practicals. List of practicals will basically introduce you to the components that we have discussed and how they work, and you can go through this list on the course web page. And project, this is very important. Let me show you some sample projects what students in the past have built. So, what sort of projects can you look forward to building? Let me give you an example of some of the projects our students in the past have built. Here is a talking gadget. It talks 3 different sensors. There is a thermometer, there is a magnetic field sensor, and it also talks time. And as you can see, this enclosure is built in the lab using a 3D printer. Then you have this is a electronic birthday blowout candles. As you can see, there are LEDs here. This body is again 3D printed, and it has its own energy source, battery source. It can be charged also. Then you have this electronic hourglass, electronic sand glass. So, when I turn it on, you will see these LEDs light up and sand falling in the form of LED lights. This box is made using a different technique, using a CNC machine. Then we have, these are electronic balloons. So, you see these LEDs here, you see red dots, they are balloons. When they light up, they will be balloons, and you can shoot a laser gun into the middle of these balloons and they will burst. They will make a sound as if a balloon is bursting. Again, this body has been 3D printed in the lab. It needs an external power supply, but rest everything is enclosed in this enclosure. And in the end, we have this Hindi word clock. Here you do not have to have any skills to read the time. The time actually shows up as Hindi words. So, you can just read off the time, and it is not a very accurate clock. The accuracy, the resolution is 15 minutes, but that is most suitable in daily life. So, this again is this enclosure is built using wood and programmed and made using Arduino microcontroller. So, these are the kind of projects that students in the past have built, and you can look forward to building something like that during the course that you perform. Now, once you have built a project, what is left is to document it, and in fact, documentation should not be left to the end. Documentation should be an ongoing process right from the beginning, from the first class. And how do you do that? Make sure that you bring a suitable notebook to the classroom and write everything that we cover in the class. Put a date. Even I see notebooks where it does not show any ownership. Please write your name and your roll number and maybe your phone number at the beginning of your notebook. So, that makes a good start to documentation, and you are going to use suitable electronic tools. I do not recommend using Microsoft Word. There is a wonderful software, a scientific software that people use for writing research papers, and I recommend you use that, and that is called LaTeX. This is not a YCivic software. What you see is what you get. There is this term called YCivic, that means a Microsoft Word is a YCivic software, but LaTeX is not a YCivic software. Here you have to tell it that I want a particular text in bold or italics, but it is a great software. It has a little bit of learning curve, but I recommend you start learning it, and you can have it's a free software, and it works on any platform that you can imagine. It works on Windows, it works on MacBook, and it works on Linux. You can download a suitable version onto your computer, or there is a version which works on the cloud. You can go to overleaf.com overleaf.com, and this is a web based, cloud based LaTeX compiler. Then this takes care of creating the document or writing the document, but what about pictures and what about block diagrams and sketches? I recommend that the software that you use for creating schematic, such as Eagle or KiCad, EagleCAD or KiCad, you can use these schematic for creating block diagrams and figures, and you can embed pictures in these software and annotate them and then export them into LaTeX. So, this will help you create good looking complete documentation. If you are using Linux, then I recommend another piece of software which is excellent, and that is called Xfig. So, your project is not complete till you document it properly. I hope this lecture, this video has given you a good introduction to what to look forward to in this course, and I hope to see you offline, and I am excited to meet you all. See you. Bye bye.